Thanks firstly to the organizers for allowing me to present our work, and thank you to everyone who joined today, of course. So yes, as Leah mentioned, this is joint work with Lukas Rudolph, who is also here today. And yes, in summary, in this project, we look at the link between the experience of extreme weather to perception, attitudes, and policy preferences regarding climate change. And specifically, we find that there are very large researcher degrees of freedom when choosing operationalizations of extreme weather. So what we do is we conduct a specification curve analysis, and for our case and our time period, we find pretty robust null results. Okay, starting from the beginning. So we know that awareness of climate change is in most developed countries is pretty high, but at the same time, public demand for climate policy does not necessarily follow suit. For the case of Switzerland, for example, just recently, the CO2 Act was rejected at the polls, which would have been very important to reach the goals of the Paris Agreement. But at the same time, the impacts of climate change have started to become more visible. And in the coming years, average citizens will be confronted with climate change more strongly and more directly. So we ask whether this personal experience of weather extremes will change people's perceptions and attitudes, and whether it also has an impact on their political preferences. We expect experiences to potentially matter based on constructor level theory, which argues that there are two different types of processing. On the one hand, we have analytical processing, which is used to evaluate objects that are distant in time, space, and hypotheticality. And on the other hand, we have experiential processing, which is used to for the direct experience and in the here and now. And what the theory argues is that experiential processing is much stronger in shaping attitudes and behavior compared to analytical processing, especially when it happens on top of analytical processing. And this is what we argue is the case here for climate change. So the personal experience of weather extremes has the potential to shape perceptions and political attitudes. We are not the first to raise this question, but prior literature is relatively inconclusive. We have some studies that show extreme weather is linked to perceptions of climate change, to beliefs that climate change is occurring, to concern about climate change, or even to support for pro-climate policies. But other studies also find no results, and we have a pretty large group of studies that finds effects depending on subgroups of respondents or on event type or temporal exposure. We argue that there are three main reasons why results so far have been relatively inconclusive, and I will go through them step by step. The first is a theoretical point. We argue that there are intermediate steps for the experience attitude links, and we try to organize these intermediate steps. So to come from experience of extreme weather to changes in political attitudes, we argue that the first step is that people have to perceive these weather extremes, right? Then in the second step, they need to attribute these weather extremes that they perceive to climate change. In the third step, they need to have an emotional relation and willingness to act. And then only in the fourth steps would we expect to see changes in political attitudes. So this is kind of like a chain. So for example, for the case of Switzerland, one could argue that maybe on step 1 and 2, we have an effect of extreme weather, but then in step 3, people are actually enjoying the warmer summers that they have because they can go swimming every day. So they don't have a negative emotional relation, and then the whole chain kind of breaks down, and we would not expect to see effects on step 4. And yeah, so that's the theoretical argument. And so far we find that the literature many times has these steps as implicit, or they are tested in different samples or different measurements. The second explanation for inconclusive results so far, and this I will focus on, is that studies so far look at very different operationalizations of extreme weather. Because when you look at the data, or when you think about it, it's not that easy to say what extreme weather is, and there is no strict theoretical starting point. So, for example, we could say that okay, we will try to define extreme temperatures based on a relative measurement, and we start by having daily measurements of mean temperature or maybe maximum daily temperature, and then what we do is we compare each day to a reference period, maybe of 10 years, because that's a period of time that people have been maybe living at the same place. So they compare to like prior personal experience. And then we check whether this the day on the calendar is more extreme than the 95% threshold of the 10 calendar year, the 10 days of the same calendar day and the years prior. But at the same time, we could also have a longer reference period, right? And look at maybe 25 years. And then the argument would be more that within the community or the people around the people, people talk about how weather has been changing. At the same time, we can also have absolute measures. And for temperature, this basically means different measures of heat, right? And there we can have different thresholds. And what we see is that, for example, the IPCC uses a definition of absolute and relative heat or extreme temperature, that is this one, but then Meteoswiss, the Swiss weather agency, uses a different one. And then if we look at the literature, and here I just picked basically a random draw from existing papers, we find that more or less almost every paper uses a different operationalization of extreme weather. So we try to organize these and have for now 20 different extreme temperature operationalizations. And then the next step is, or the next question, does it matter, right? And for that, I show you two maps of Switzerland. These are two different relative extreme temperature measures, operationalizations. So what you see is the map of Switzerland. The dark gray areas are areas where no one lives, so the mountains basically. And each dot is one of our respondents. And on the left-hand side, the map shows you an operationalization that is in comparison to a 10-year reference period, and it's built on mean temperature and a 95% extremeness threshold. And we see that 5 to 11% of days between waves are measured as extreme. So all of these measures go from 0, which would mean that no day between the waves, between the survey waves, is extreme, or 100, which would mean that each day is extreme, or every day is extreme. And we see that, for example, Zurich, which is somewhere in the middle, and Ticino, which is like the very south of Switzerland, have like comparable levels of extremeness. But then if we look at a different operationalization, which is built on a longer yearly reference period and a different extremeness threshold, we find that in some regions, basically Ticino, some respondents, every 4th day for them is extreme. And we see that here, Ticino is much more extreme than other regions. So these are just two operationalizations, right? In total, we have 10 just in terms of the relative measures of extreme temperature. And you can see the density plots of the two I presented here. And you can see that they vary a lot, both in terms of distribution, like variance, minimum and maximum values, but also in the geographical dispersion. But what I presented so far was just the extreme weather in terms of temperature, right? We also have rain data, which has the very same structure as the temperature data, so daily measurements. And we also have extreme weather events, which we have from a database that collects data on mudslides, landslides, and floods. They are also geocoded. So in total, with all of these different types of extreme weather, we have 32 different operationalizations. And our argument is that as we have no strict theoretical reason to choose one over all of the others, we should use at least many, or in this case, we use all of the operationalizations of extreme weather. And then the third reason for different results is obviously research design. In our case, we have a pretty strong setup. So we have panel data based on the representative sample. It comes from the Swiss Environmental Panel, which is a panel study that is run twice per year. We have data from the very first wave, which was conducted in April 2018, and then the fourth wave, which was conducted in December 19. As it is an address-based sample, we have geocodes for all of the more than 3,000 respondents who took part in both waves. And due to the geocoded respondents, we can link them to objective weather data, which means that we have no endogeneity issues with self-reported weather experiences, but we have the weather data from Meteo Swiss again. It's pretty fine-grained, so it's on a 1x1 kilometer grid, and it's daily measures. For temperature, we even have mean and maximum temperatures, and for rain, we have averages. And then we have the extreme weather events in the municipality. Our model setup is relatively simple. So we regress the wave 4 value on the wave 1 value for all of the dependent variables, which are the 4 theoretical steps that I introduced. And then we have the main independent variable, which is the weather operationalization. And then we swap the core dependent variables and run through all of the core independent variables. And because there's quite a lot of them, we use specification curve analyses to show the effect of weather depending on the operationalization. So what you see here in the plot is such a specification curve analysis. So each of the dots and the bars is the results of one of the weather operationalizations, and 95% confidence intervals. They are ordered by magnitude, so from the most negative to the most positive. And the blue ones are the ones that are significant at a 95% interval. Yes, so this is for step 2, attribution to climate change, which we have in the survey as the survey item. I don't believe that global warming is really happening, which is reversed. And then what we see is that we have results that range from relatively negative but not significant to some of them which are positive and significant. But all in all, 4 out of the 32 operationalizations are significant. Yeah, the dependent variable is measured on a 5-point scale, so the magnitude of all of the results is not too large. And if you remember the different the operationalizations by the IPCC and Meteo Swiss, we can come back to those and see that actually the largest and the smallest effects are the ones by the IPCC and the one from the like the Swiss government. I will show you one more step. We have quite a lot of steps and quite a lot of survey items, but I can't show all of them today. So this is one for step 4, the political attitudes, where we have an index made out of 5 different policy items. It's just an additive index for which we have in both of the waves. And here you can also see that we have 9 out of the operationalizations are significant, but some of them are even significantly negative, which is the opposite of what we would expect it. And just to look back at the official operationalizations, some of them are positive but non-significant. One is positive and significant, and one is very close to 0 and non-significant. And one thing that is also interesting with this step is that some of the negative, significantly negative results come from some of the summer specifications, where we only look at the summer periods, whether they were extreme, which was one of the starting points why we started this project, because Switzerland had just lived through the 2 hottest and driest summers since starting of the weather writings, but they have like significantly negative results. So in summary, we find for the time period that we have data for from between spring 18 and fall of 2019, which included 2 extreme heat waves, no effects or like robust null effects of extreme weather on perceptions and attitudes. And we kind of want to introduce this kind of research template, both in terms of the 4 steps between experience and attitude changes, and the different operationalizations and how to include them in a specification curve analysis. Thank you.